Hello, guys, and welcome to episode 2 of Making a Snake AI in Java. So, for starters, I added one update to the snakeboard class, and that is getting an input value. I tweaked the value slightly, so it's a 0 for an apple, 50 for an empty tile, 75 for a body tile, and then 100 for a head tile, and then converting that into a double and dividing it by 100 to get the neurons for the input layer, and then returning just in a double array for that. And then I added in a neuron class has a single bias double, and then an integer array, a double array of weights that's based on the size of the previous layer. And then set random just initiates them all to values between -1 and 1. Can always change that layer later to see if I can improve performance, but we'll get to that when it actually becomes relevant. And then I added a get value method, sets the value to 0, goes through, given the neurons of the previous layer, multiplies them by the weights and adds it to the value, and then adds the bias to the value, and then returns the sigmoid of that to get a value between 0 and 1. Returns that. And then we have the entire model, each individual model. It has a two-dimensional array of neurons called layers, and then it's initialized with the number of layers, the number of hidden layers, and then the layer size. And so it's created to be number of layers plus 1 just to account for the output layer. And then for the number of hidden layers, it sets that part of the array to have a width of layer size. And then the last layer of the array is set to have a size of 4 for the 4 possible outcomes. And the greatest of that is just chosen to determine what move is being made. And so the previous layer at the start is 90 because it's a 10 by 9 grid, and that's being fed in. And then it just goes through and it creates all the individual neurons. And then to initiate at random, it just iterates through the entire layers array and sets all the neurons to random values for their biases and weights. And then we have the find best move command. So it takes in an input layer, which we can get from the board.get input method. And then we get a double output layer is created. And then for each layer, the output layer is a new double. It's created to a new double based on the length of the individual layer inside of layers. And then for each neuron in that, the output layer corresponding to that neuron is set to the neuron's get value given the input layer. And then the input layer is set to a clone of the output layer. And then this process repeats until it's gone through all the layers. And then by the end, the last thing, both the input and output layer should correspond to the neuron values for the last 4 neurons. And then the greatest one of those is chosen, and then it's returned. And I just have it print out all the values just so we can see how exactly they're changing. And that's about all I have. I just set this up. I created a model called Timothy. It just has one hidden layer with 8 neurons for now. I'll tweak it later once I add the mutations and then the reproductive abilities. But Timothy, he's just initiated to a bunch of random values, so he's not going to play the game particularly well. And then the board is printed out. The move is set to him finding the best move, and then this repeats until the game ends. So let's see exactly what score Timothy can have here. I should add forgot to copy and paste this into the thing. I need to remember to add that, but we can say how good Timothy is. He's might get 1. It's basically just a 1 in 4 chance what direction they'll move in right now. But later, hopefully, we can see they'll start to move towards the first apple consistently, and then from there, hopefully, they'll be able to path to the next ones after a few generations. We'll see if that actually works, but yeah. All right, just cleaning that up. All right. Now it is time to run it. Let's hope I didn't accidentally add a syntax error somehow. Oh shit. Okay. Angus Blackburn, thank you. I appreciate it. All right, there we go. We can see. Here we go. Oh, this time it moved down. You can see the neurons, the value, like they changed very slightly because the position is changing of the snake, and hopefully that change will eventually amount to it being able to path in the correct direction. So let's see if I can get it to get a score of 1. It's basically just a random chance. You can see this time, because it's randomly initiated, it decides to move up. And then, again, maybe if we're really lucky, it will change direction. Okay. Come on, you can do it. Get a score of 1. Oh, there we go. Let's go. Yeah. I was able to get a score of 1, and that's the best that the random ones are ever going to do. So, in the next episode, I will implement and run through the mutations, the random mutations to the neurons that are going to be implemented, and then also the system of removing the least fit snakes, or the least fit models. I guess you can call them snakes, and going through that. And then maybe also some stuff with optimization. I'll see exactly how long it takes to run a simulated game. Right now, this was almost instant, so we should be able to run through 100 generations in probably under a minute. But I'll just see how it works out. Thanks for watching.